today's webinar is going to be multi-cavity meshing workflow inside Moldex 3D. So it's more of a tips and tricks presentation for the folks who are already using Moldex 3D. And this is not only going to help you on the high cavitation. Yes, the focus is going to be on the high cavitation, but there is something, some takeaway, even if you don't have high cavitation mold, just to get high level of accuracy with your simulation and mesh it much more faster. And I would like to introduce myself as well. I'm Harshal, located in Chicago area, helping the team on the sales and implementation side of the business, and been in the simulation world since 9 years now, working with molding companies who are frustrated by production problems like shrinkage, warpage, air traps, and they're trying to figure out where is it coming from. Is it the part design, or is it the tooling or processing? And some of them are concerned by trial and errors that goes during processing and mold revisions. So trying to help them through Moldex 3D simulations. So with that, let's get into today's topic. And it's a very short presentation, but I'll try to make it as much as useful for you folks in your work environment. All right. So today what we're going to do is we're going to look at the workflow for multi-cavity meshing, right? There are two major types. One is full model analysis, and another one is symmetry. What does full model analysis mean? Basically what it means is, let's say you have a mold, you bring it in and you run the simulation on the complete mold, considering all the cavities, the entire runner system, everything, right? That's called full model analysis. And what is symmetry? Symmetry basically is running a simulation on a part of the mold, but getting all the information you would get, from the running the full analysis. The benefit is you save so much time, energy, and resources, and get to the answer as fast as possible, right? So that's the benefit of symmetry. So we're going to talk about what is this and why do we do it, and when do we use it, right? We can also show you some buttons on what to click inside Moldex 3D to run this symmetry setting. And then we're going to talk about different approaches, when it comes to like a multi-cavity tools and meshing multiple cavities and the runner system. One of them is the line-defined runner approach. So we'll talk about what it is, why line-defined runner is important, when to use it, and also we'll talk about the process on how to go about it inside Moldex 3D. And another one would be solid geometry runner approach. Right, so we're going to talk about what it is, why we use this, in what situation we can use it, when we cannot use it, and yeah, so we're going to walk you through that process of what this solid runner meshing is. And towards the end of this presentation, what we're going to do is we're going to talk about cost-effective progressive analysis. What it means basically is how can we efficiently run simulation? What are different ways where we can shorten the simulation runtime, right? And majority of them we're going to cover it today, which is through meshing, right? So we're going to talk about various different approaches: coarse grain versus fine grain analysis, single cavity optimization, considering the actual cavity, full runner system optimization, like when you are at the stage where you are trying to optimize your runner design, like what do we need to do in that situation, right? So we're going to share some tips and tricks in regards to that. And then we're going to talk about combining both of them, right? Optimized cavity and optimized runner together for a complete, cost-effective progressive analysis.